We are in Cantù today. It is the fourth coordination meeting of ConstructAdd. We are hosted by BLM group.
Hello, my name is Andrea Crosato and I am the technical director for the laser division in BLM. In these 2 days, we have hosted the ConstructAdd consortium for the midterm meeting. We have visited the R&D laboratory in our new production plant in Cucciago, and today we are going to visit the showroom in the headquarters in Cantù.
It's the end of the first year and a half of the project. We have 2.5 years more to go, so getting close to the middle of the project. We have interesting lessons learned already. I can classify them at 4 points. First of all, we started with an idea to test high-strength steel with 4 different printing technologies. Try to understand its mechanical performance, metallurgy, and how can we exploit that for the construction and automotive industries. Happy to say that the results are very promising. Today, at this moment, our colleagues from different departments, from metallurgy and mechanical departments and companies, powder producers, and construction companies have been discussing on this. So we have obtained high-strength steel metal components using powder bed fusion, direct energy deposition with powder and wire arc additive manufacturing. The second lessons learned was about structural optimization of construction parts. Starting from organic and complex shapes, we merged to functional components that are solving geometrically difficult problems at local level, so that the components have a higher service life considering fatigue phenomena. And we already have demonstrators ready to be printed, and in this meeting in Cantù we are giving them the final touch. That the third point that we learned in the first year and a half is about the standardization. Our partner DNV prepared a very detailed report about how our efforts in metal 3D printing and construction can be relevant and close for the standardization bodies. So we have a report showing how and at which points the project results can be relevant for our standardization route that we are going to take. And the other lessons learned in the first part of the project was preliminary results about life cycle assessment. So in the project, our aim is to quantify how much it will cost and how much we are able to reduce the environmental impact of construction and automotive products using metal additive manufacturing. And what is next? We have 2 years and a half to go. Now we are starting experimental activities. So what is designed and planned in the first part of the project now will be in the lab, printed, tested. We will have numerical models calibrated on the test results, and all these will be used to give some guidelines and proposals for the future standards for the standardization bodies.
It has been 2 years since the project started. Could you provide insights into DNV's role and elaborate on your overall contributions?
Thank you. DNV is the work package leader, WP5. This is about performance, compliance and CE marking, where DNV is guiding together with other partners how a compliance document can be prepared in a simulated way. so that the project results can be adopted by the industry after the project within a short time. So DNV's role is more to guide standards and awareness of standards and compliance. This is what our main role.
What contributions have you made thus far?
So to begin with, DNV has started exploring how there is a gap between the additive manufacturing requirements versus the gap between the harmonized standards. To fill this gap, or actually to map this gap, we have prepared a detailed report that completely details about what are the compliance route options that are suiting to the various demo parts that we are making in this project. So that is that was one of the report we made last year.
What ongoing initiatives are in place and how will they benefit partners presently and in the future?
We are working currently now with many partners, making templates for material certification, factory production control, etc. These are the simulated reports, but however, in future, when these partners go to real production or when there is a need for the compliance according to the European requirements according to CPR, so then the reports we are making now will be very useful for the partners to report the compliance.
Can you describe more about the standardization activities across Europe and suggest some relevant European committees or work groups that ConstructAdd partners could join?
Technical committees playing a crucial role in Europe regarding developing and making new standards for industry use. And DNV has provided some technical committee lists to partners and asked to join committees. As one of the committees is CN-TC 135 Working Group 15 for EN 1090, CN-TC 250 for Eurocodes and several subcommittees. And also one of a crucial committee could be CN-TC 438 for additive manufacturing.
In traditional steel construction industry, which technologies or production processes appear near to be outdated or integrated by additive manufacturing?
At a first glance, we can argue that casting is one of the first, but all the steps of production in steel construction, from simply the way we do a slot or a hole in a structural node, could be affected, up to the way we transport and deliver steel on site and the way we launch a bridge or build a stadium.
What about nodes and joints in steel structures? Why the structural design and the industry circuit has so many expectations from additive manufacturing?
To be very clear, joints and nodes strongly affect productivity while giving poor structural performance due to sharp changes in geometry. For a normal stress running straight on an E-beam, fatigue performance, for example, drops brutally 64 times if it finds a weld toe.
On this point, optimization seems to be the key to reduce costs and rise performance, isn't it?
In the recent past, the word optimization has been used to describe a point to be reached in a mathematical algorithm on a single domain frontier. For example, in structural steel fan models, a minimum of von Mises stresses. It's important in my eyes to also add the other domains for more complex frontier fields, having in mind that some important aspects as transportation and methods of site construction can have a huge impact on the optimum.